Welcome to the course Business Analytics and Data Mining Modeling using R. So, in the previous lecture we were discussing performance metrics, and specifically at the last part of the lecture we were discussing oversampling approach, especially in the scenario where we are dealing with rare class members, where the class of interest members belonging to the class of interest, they are very few in the sample. So, we talked about different things related to this particular approach. We talked about that there could be two oversampling approach, one being that we can sample more rare class observations, and the second being that replicate existing rare class observations. So, we focused more on sample more rare class observation, which is equivalent of oversampling without replacement. Let us also understand few more situations through using some graphs. For example, when we are dealing with two class scenarios where the classification costs are equal. So, we are dealing with equal misclassification cost, the scenario where we are dealing with equal misclassification costs, and we have two class scenario as we discussed in the previous lecture, and these two classes being class 1 and class 0. So, if there are more records belonging to class 0 being represented by 0 itself here in this graph, and there are few records belonging to class 1, right, and we are in the scenario where we have equal misclassification cost. So, one particular model could be this one. So, this line will separate the records, will create homogeneous partitions, and also minimize the misclassification error, right. This is homogeneous, all the record, there is just one record there belong to the same class, and here most of the records belong to the class 0, just one misclassification error. So, this is the case when we are dealing with equal misclassification cost, and this is how it is going to work out. The another scenario could be when we have asymmetric misclassification cost, and the same scenario, two class scenario, class 1 and class 0. In such a situation we might be interested in, as we discussed in the previous lecture, we might be interested in identifying more of the class 1 observations, even if it comes at the expense of misclassifying more of class 0 observation. So, if we try to plot the same points here, so our model could be represented by this particular separator line, right, this particular separator. Now, you would see that in the upper partition we have all the observation belonging to the class of interest, that is class 1, and in the lower half we have all the observation, this is homogeneous, belonging to class 0. So, this is more desirable when we have asymmetric misclassification cost, that meaning that there is one specific class of interest, and we would like to identify more of that class, even if it comes at the expense of misclassifying some of the other observations. Now, when we talked about this oversampling scenario, that these rare class members, they could be very few in the sample. So, what we can do about that? So, we talked about that oversampling, two oversampling approaches could be used. Sample more rare class observations, that is equivalent of oversampling without replacement, then another one being replicate existing rare class observation. So, we further talked about what is the typical scenario that is followed by analyst. So, they generally sample equal number of respondents from both the classes, right. So, that is the typical approach. So, we talked about when we follow this approach, irrespective of the oversampling approach that we follow, that oversampling adjustment we will have to perform for our performance evaluation, right, to evaluate the performance of the model. Right, we talked about two particular scoring methods for validation partition. So first one was to build your model on oversampled training partition and then test it on a regular validation partition. So that is indicated by the first one, validation partition without oversampling, that is regular or the original validation partition. Now second one being oversampled validation partition, and then remove the oversampling effects by adjusting weights. So sometimes the number of rare class cases could be, class of interest cases could be so few that even that validation partition without oversampling might not remain practical, might not remain useful. In such situations, we might have no choice but to oversample even the validation partition. So we will be building our model on oversampled training partition, as well as we would be evaluating our model on oversampled validation partition in those situations. Now we also talked about a few typical steps in rare class scenario that are generally taken. So as we discussed that equal number of observation from both the classes, the same thing can be said, that training partition with 50% class 1 observation and 50% class 0 observation. So equal number of participation. Now validate the models. This is the this is the approach one that we actually would like to follow, that validate the model with validation partition drawn using simple random sampling taken from the original data set. So the regular data set. So we would like to have validation partition taken from the regular data set. Now to clarify these steps a bit more, to have the detailed steps of this particular process, we have listed them out, all these steps. The first one being separate the class 1 and class 0 observations in two strata. So we talked about in the previous lecture that a stratified sampling is generally used for oversampling. So the very first step itself is talking about the same. So we can whatever the number of observation that we have in our sample, we can separate the class 1 observation from class 0 observations, and we can create two strata or two distinct sets of those classes. Now because we would be requiring training and validation partition at least, so therefore it would be advisable to use half of the records from class 1. We can select half of those class 1 records randomly and then put them into training partition. The remaining half of class 1 records, they can be reserved for validation partition or even for test partition. We will see as in the next few steps. So half the records from class 1 observation, class 1 stratum can be randomly selected. The remaining class 1 records are reserved for validation partition. Now next step would be randomly select class 0 records for training partition equal to the number of class 1 records that we did in step 2, so that we are able to maintain that 50% records coming from each of the classes, right, from both the classes we would like to have this equal number of records. So what we did in step 2, the same number of records we can also randomly select from class 0 stratum. So the next step would be randomly select class 0 record. Now so till step number 4, so we have been able to create our training partition, so we can do our modeling. So we can build our model, then later on when we will require to evaluate that performance of that particular model, we would require validation partition. So step number 5 onwards, they deal with creation of validation partition. So you would see step number 5 is randomly select class 0 records to maintain the original ratio of class 0 to class 1 records for validation partition, because we said that our first approach would be to test the performance of this being the direct approach also, that build your model on oversampled training partition and test it on regular validation partition. So, to build the regular validation partition, we would like to randomly select class 0 records, and the half of class 1 records we already have. So, we would like to maintain the original ratio that was there in the regular data set. So, in this fashion we can create a validation partition. Now, this could be used for performance evaluation, but if we want a further test partition, because sometimes the validation partition could also be used for fine tuning the model, and therefore it also becomes part of the building process of the model, and therefore test partition is very much required to evaluate the true performance of the finally selected model, right. So, therefore, if you want test partition also, so the validation partition that we have created during step 5. So, from that validation partition itself we can randomly draw a sample for test partition. So, in this fashion we can perform our modeling. We can oversample if there are class of interest, there are very few cases. We can do oversampling for the training data set, and we can prepare our validation partition accordingly, so that it is as per the proportions in regular data sets, and therefore we can go ahead and evaluate the performance. Now, as we discussed that there might be situation where validation partition without oversampling, the first one that we just talked about, the detailed steps we talked about, that might not remain practical, that might not be useful. Reason being, due to very few class 1 records, that so few records that half of the records for training partition and reserving half of the records for validation partition, even that might not be feasible or practical, and therefore the modeling might become a bit more complicated. So, we have to follow the second approach. So, second approach was to oversample even the validation partition for evaluation as well. So, this validation partition is going to be used typically for evaluation. So, we are going to use the oversampled validation partition, and later on we will have to adjust the weights to get rid of oversampling effects. So, we apply our model that has been built on oversampled training partition. Then we test the performance of that model on the oversampled validation partition. Then we readjust the weights that we get there, and so that we can get rid of the oversampling effects. So, now because this is main idea is about evaluation of the model. So, adjustment that we require is on validation partition classification matrix that we get when we test our model on validation oversampled validation partition. So, that adjustment is required there, and lift curve can also be adjusted accordingly. Now, what we will do an exercise in Excel for this, whatever we have discussed till now. Let us go through an exercise. So, this is the scenario. We have oversampled validation set. Now, the assumption is that the sample that we have, the original response rate is 2%. That means the response variable, the records belonging to the class of interest, they are just 2%, and the other records belong to the other class 0. So, records belonging to class 1, they are just 2% of the sample, and the 98% of the records in the sample, they belong to class 0. So, when we do oversampling, we try to increase this particular ratio, this particular proportion, and we make it 50%. So, we oversample in such a manner that now the response rate it increases from 2% to 50%. So, now in this oversampled data set that we have, we will have 50% records belonging to class 1 observation class of interest, and the remaining 50% belonging to the class 0 observation. Same, you can see that validation partition size after oversampling, if it is 1000, then the number of ones in this particular 1000 records are going to be 500, and number of zeros are going to be 500. Now let's say we build our model on the oversampled training partition, and then later on we applied that particular model on oversampled validation partition. So as a result of that validation exercise, we got this classification matrix, this validation classification matrix. So you would see, so because there were more than usual response rate because of the oversampling, you can see the results. This could be one example of this classification matrix. So you can see 390 for class 0 members classified as class 0, then you have 420 class 1 members classified as class 1 members. So in total you have 500 class 0, 500 class 1, total 1000 records in the sample, right. So if you want to compute the classification rate in this fashion, as we have discussed before, that off diagonal elements, that is 80 and 110, and then it would be divided by the total number of records. So that will give us the misclassification rate, that is 19%. So when we do oversampling, this is the misclassification rate that we get, but this is on the oversampled validation partition. So this is going to be slightly less than what could have been there in the regular data set scenario. So if you look at the number of percentage of class 1 records, so you can compute this also, right. So this comes out to be 53%. So 53% records have been classified by the model as belonging to class 1. Now to assess to evaluate the true performance of the model, right, we need to adjust the weights. So there are two ways: either we remove ones so that we are able to maintain the original proportion, or we can add zeros so that we are able to again get back to the original proportion. Now the typical strategy that generally we follow is adding zeros to reweight the sample to achieve the original proportion. Now how that can be done? You can see that, let's say validation partition size after reweighing is x, right. So we are going to use some of the utilities that are available in Excel, specifically goal seek. This is an easy equation that we can solve manually as well, but because we are using Excel, so we like to use some of the utilities that are available there. So if we want to add extra zeros so that we are able to reach the original proportion, so we need to find out. So this new sample size would be much bigger. So so this is going to be the equation that will give us the new sample size. So earlier one was 1000. Now we want new sample size which will have the original proportion of different class members. So 500, if there are 500 ones and we are not going to change this particular figure, so we would like to add zeros. So 500 representing the 2%. So original response rate was 2%. So 500 value of number of ones is representing now the 2% of the response rate. So therefore we need 98% of zeros here. So we will this is how we can write this equation: 500 plus 98% zeros. So therefore 0.98 into x. X is the total number of records that is in the new sample after reweighing, and that has to be equal to the total number of records. So 500 plus 0.98 x equal to x. So if we solve for the value of x, so we'll get the new sample size after doing weight adjustment. So the same equation can also be written in this fashion: x minus 0.98 x equal to 500. So this being suitable for us to be able to use goal seek function in Excel. So if you want to use goal seek function, which we have already done, for example, we want to solve for x. So this is the x, and this is the cell that we have reserved for the value So let's find out this. So you go into the data tab, and then you would see this what if analysis there, and then there you would see that goal seek is there. So the set cell, there we need to specify the cell where this particular formula is there. So formula what we have written in this particular cell, right, and then the value that we want to target, that is 500, right. You can look at the new equation. So this is what the equation that we are trying to target. Now the formula has been written there, so we'll have a look at the formula. The formula is actually this representing this particular expression x minus 0.98x. We'll just see what we have formula we have written in that particular cell, C16, right. So the value that we are targeting is 500, that is right hand side of this equation, and we are changing the cell, this one, C15, which is representing the x. So we want to change this particular cell, and if you just run through, so we'll get these values which are already there, because I had ran this particular goal seek utility before. Now look, if you want interested in the formula, this is the formula that we have written there. So this particular formula is representing this equation x minus 0.98x, that is going to be used by the goal seek function, as we just saw. So you can see C15, so this is the value, C15 is this x, right. So C15 representing the x minus 0.98. So that this is how we are computing this 0.98. 1 minus b2, b2 is the original response rate. So 1 minus b2, it's in percentage. Excel will take care of this percentage notation, and it will appropriately convert it into 0.2, and therefore 1 minus 0.2 will become 0.98. So we will get that value. Then again this is again 0.98x, so again x being C15. So this is the formula that we have written there. Now as we saw that we can run the goal seek function, and we will get this value 25,000 here. So this is the 25,000 is the size of validation partition after reweighing. As you can see, validation partition size after reweighing is 25,000. Now 500 ones were there, so the remaining number of zeros would be can be very easily computed using this formula or manually as well for this particular case. So 24,500 zeros are to be there. Now once we are done with this particular calculation, now we can adjust our matrix, validation classification matrix, using this particular information, the new sample size and the number of ones and the number of zeros. So here, as you can see in this classification matrix, now we can fix these values here. You can see B17, this particular value, number of zeros, this has been fixed using this number. Then the this has also been fixed using this number of ones. Total is also fixed using this number C15. And then we are now we need to adjust the values that are there in this two cells, the cells for class 0 members. So you can see that class 1 members, they are unchanged, right. So because they were 500 and we do not want to make any change there, so these values remain unchanged as same as the previous matrix. Now the two values that we need to find out is these two values, right. So the how we can do this is we can keep the ratio that was there in this particular matrix that we got from the model, right. So we need to maintain this ratio 390 to 390 and 110 for the total number of observation of 500. So this ratio we need to maintain 390 divided by 500 to 110 divided by 500. So this ratio for class 0 and class 1 we can maintain, and we can compute this new number. Total we already have. So in this fashion you can compute, you can see this, that 390 divided by 500, this is the ratio, and total number of observations are 24,500. So we will get the new number of zeros in that particular cell. Similarly, this one can also be computed, this particular cell value. You can see once again 110 divided by 500 as represented in C8 divided by D8, and then total value being 24,500. So the number has been appropriately calculated by Excel. Now we can also get these values, predicted class zeros, number of predicted class 0, and number of predicted class 1 records using this particular sum function. So in this fashion we will get the new validation classification matrix after reweighing. Now once the weight adjustment has been done, we can use this particular new matrix to compute adjusted misclassification rate. So now following the same procedure as we have been using before, we can look at the off diagonal values to find out the error, and now we get the new number, that is 21.88%. Now the earlier misclassification rate was 19%, which was slightly lower than this number 21.88%. So now once we are able to remove the oversampling effect, you can see that misclassification rate has jumped to almost 3 percentage point, right. And if you look at the percentage of class 1 records, right, now they have come down. So earlier we had 53% in the oversampled partition, validation partition. Now the new numbers, as you can see, this is how you can compute C22 divided by D22, these two numbers, right. So you can see the new percentage is 23% of the records they have been classified as class 1. So let's go back to our slides. So in this fashion, what we were talking about, that if we had to use the oversampled validation partition, then how do we go about evaluating the performance of our model? So we will have to adjust the weights. We have to adjust the weight so that we get the new validation matrix, validation partition, this classification matrix, and then that can be used to compute the misclassification error. Now the lift curve can also be appropriately adjusted so that we can again compare the find out the efficiency of the model for the oversampled validation partition case. So you can see the same thing is being discussed here, lift curve on oversampled validation partition. So how to create that? So the steps that we have been following earlier, right, the lift curve that we had created before, the same steps can be followed here, right. Let's go back to our Excel file once again, and let's look at what when we created lift curve. So this was the data. So the steps that we followed, that we sorted the probability, estimated probability scores from in the decreasing order, starting from the highest values to the lower values, and the actual class was also given in the one more column, and then the we had net value, because this was the case where we were incorporating the net value, right, and we were plotting the curve accordingly. So net value and cumulative value we used to compute these columns, and then that these values were used to plot the lift curve, the cumulative value column and the serial number column. So this is how we used to do this. Now if we look at what we need to change here is we need to multiply in one of the steps in the intermediate step, that we need to multiply the net value of a record with proportion of class 1 records in original data. So net value of a record, for example, if we look at the this particular column number 4D, column net value, so there we need to multiply this value by the this ratio, this proportion of class 1 records in the original data. So that can now be used to compute the new values, and then those values can further be used to compute the cumulative value, and once we have those cumulative values, we can plot our lift curve using on oversampled validation partition. Now that lift curve would be adjusted for this oversampling effect, and we would be able to find out the effectiveness of a particular model. Now there are a few more things that we can discuss especially in a two class scenario, right. One is that sometimes we might want to have some records would be there which might not be appropriately or correctly classified by our model. So So can we have some other way to overcome this problem? So the records which are difficult to classify by our model, we can label it with a third class option, cannot say. Now once this kind of modeling is done for all the records, so most of the records, they would be classified as class 1, or some other records would be classified as class 0. The few records which are difficult to classify, they can be labeled as cannot say, and then expert judgment can actually be used whether to classify them as ones and zeros, right. So this kind of configuration can also be used in a 2-class scenario. So we will stop here and we will continue our discussion on performance matrix in the next lecture. Thank you.